Good morning. Today we're going to start putting together a bunch of the stuff that we've worked on in the past. So, I'm going to get started by, I'm going to be creating a mechanism for importing all the different VDB things that we've been working on, as well as the various different orbits that we used. So, let me go ahead and see if I can just go ahead and get started. I'm going to just get started. Alright. Alright, so, as a reminder, what we've got is we've got two spheres orbiting each other, and then what I want to do is I want to put stuff around on the outside of them to show the energy that's coming off of them. So, let's go ahead and create a new window here. We'll do separation fast. So what this does here, as you see, this gives us N32. Oh, that's the wrong one, actually. Separation. Yeah, here we go. So what I'm doing here is we have these coalescing objects, and then using this, we can come up with our, we can extract using the MayaWaves library from GT0577 our positions. What this ends up looking like is this. So this gives us our X, Y, and Z. We assume that our primary object is at, oh, I'm sorry, what this does is it gives us X, Y, Z and our distance. X, Y, and Z here are the vector directions. You'll note that Z is almost always 0, or at least close to 0. And then this is the actual distance. This is the time. So given all these different things, we are then going to, oh, and this is our orbital X angular momentum, Y angular momentum, Z angular momentum. So you see that's basically 0, 0, 1 to rounding precision. So let's go ahead and create our sphere here. We'll add our central sphere. I'm going to do icosphere just because that with the uniform surface coming off, or with the uniform size surfaces, that makes a few things a little bit easier. We'll add a second icosphere. We'll deal with their positions later on. Let's rename this one primary, this one secondary. Okay, so let's go to our geometry nodes, create a new one for secondary. Let's see, do I have my CSV importer? I do. So we will import our CSV. It's under DXL, GWave, BHmerger CSV. What? Oh boy. We've got the wrong version of NumPy installed. Okay. Let me check that error again, and I'll just manually modify the code. Data bpy attribute use float64 182 in data bpy. Okay, so I'm just going to manually fix this up. What did I do wrong? It's pulling it from a different directory, isn't it? Okay. It's probably importing it into my yeah, it's in .config. Oh, and I never played my music, did I? All right. There we go. I'm going to listen to Ween today. Nope. .config. Blender. Extensions, local lib, Python, site packages, data bpy. MP float underscore attribute. All right, so now let's try it. Yeah, I probably just need to reload. Don't save. Ba, ba, ba. There we go. All right, so now we have the CSV BH merger. It's an object. Let's go ahead and we will rename this one actually to secondary. So let's go to geometry nodes. We will icosphere. All right. Now read named attribute. So we've got vertex groups don't exist. What? Great. Is it actually supposed to be float 32? Well, let's give that a shot. Oh boy. Yeah. I wonder if there are other issues with NumPy 2 that I'm just not seeing. Might just need to revert. I'm not seeing anything here, so let's take a look here at, attributes. Okay, well that did seem to, at least for the moment, fix it. Yeah, there we go. All right, so we've got our input geometry. It's only 32. I'm probably going to want to increase that, but we will do points, and we'll do that based on domain size. This is from the mesh. Number of points to create. Let's get rid of our cube. All right, so now we've got 32, I think. Yep, 32. Great. So that gives us all of our points. Now all we need to do is read attributes. We'll do our named attributes of x, y, and z. Okay, so this is our directional vector. So now we combine these. Okay, and now we set position. Oh, can I supply this here? Let's see. No, I guess it wasn't picking them that way. Okay. So they all, let's see, now my output, no, look at that. Oh boy. All right, let's add a viewer here. Link to viewer. Yeah, there we go. is combining x, y, z. Let's see, can I link that to a viewer? All right. All my points. Oh, it's not set in position. All right, well, let's go ahead and leave those where they are. Set position. Let's geometry that right in there. Now we will combine that with that. Oh man, it's gonna be the same thing. Link to viewer. All right, let's instead do geometry. We'll set this to points. All right, so meshed points. There we go. All right, so this is our set of positions, and now we should be able to points to curve. Nope. So now we've got a bunch of curves there. I'm going to go back and I'll update my CSV so that it's a lot more well populated. Now let's go back here. We'll take a look at time. We're going to set these each to keyframes. No, I can't do that. Right. Forgot. So let's go back and edit my here. Let's do n equals 512. Should be sufficient. Oh, right. It actually takes quite a while, doesn't it? I forgot. All right, well, I will come back to that. We'll just do 64. We will let it sit for a few minutes. All right, now let's do, we'll sample our curve here. Put that here into curves instead of into that. And what we'll do is we will take an icosphere, and we will set that as what we position, and then we will query the set position. So set position of this geometry to factor. We want this to go out to about 240, or 250. So hash frame divided by 250. And so now we do our position. Oops, what just happened? There we go. Take our position and put it there. Now we output this. Okay, we got that. So we've got our sampling on our curves, got our icosphere. Let's crank it down to 1, subdivisions 5. Let's set it down to 4 so that it's a little easier. Then we've got our sampling of our curve. We've got our points to curves, curves. How many curves are there? Let's link to a viewer. Spline 1, curve type 1. Okay, so we got our curves going in there. Sample curve at value. No, we actually want position. Nope. My icosphere seems not to have worked. Alright. -1. Yeah. Oh, it's just giving me 1. No, that's exactly where it should be. -1. 10 to the minus 22. Huh. But it's not showing up. Well, we'll come back to that in just a minute. Let's see if we do. Nope. Oh, I'm setting all the vertices to the same point. Of course. So, transform geometry. Position. There we go. All right. So now, see, it's a real ugly orbit. We also now need to combine our vertices in that, and we need to read a named attribute and use that as a scale for our vector. We will scale our vector. So this is our geometry here has the named attribute D, I think. Yeah, D. So we'll read the named attribute D. Scale that there. And so now, and it's going to look pretty, yeah, look at that. All right. So we've got our object. It's coalescing. But we really don't have sufficient sufficient resolution. You see how it's all over the place there? Here, we can double the resolution now if we do this. Here, I will save these geometry nodes as orbit from XYZD. So we delete that, import new CSV. Oops. Let's add a modifier, geometry nodes, and it's going to be orbit XYZ. So let's see now what it looks like. We've got, yeah, it's a little bit better. It's certainly whipping around like that. Let's add our primary here. Let's stop, go back to the beginning, add another mesh. This will be another icosphere. We'll call this our primary. This will be our secondary. So let's see if we can speed this up a little bit. So in the past, what I found was that accessing the HDF5 files for this particular type of thing could occasionally be a little bit faster. So let's take a look at what we've got in the HDF5 files. So we've got these compact objects. This has 52, 52, 46. These are probably the objects 0, 1, and 2. All right, let's take a look. see, compact object. Oh, right, it doesn't have keys. Let's see. Let's see what header is. Okay, so there's 52. So this gives us our values. So X, Y, and Z. So let's take we'll put this into pandas just in case. Or we'll import pandas just in case we need to output it. So we're gonna figure out with h5py gt 0 is equal to f. Okay, a 1. Now, I don't know what object 2 is, so we will eventually take care of that, but for now, what we'll do is pd.dataframe. You know what, let me run this interactively. Run positions.py 01. So let me just mask out nans. We'll do any along axis 1. So we've got this mask nan 01. Oops, I want this the opposite of that. No, any instead of. There we go. Huh. Well, that's fun. You know what? Let's. We want to do that for each of the individual ones. We'll do a drop NA with pandas. So df0 is equal to pd.dataframe 0 columns equals 0h. Okay. All right, so we will now do data frame 0 O0H. Do the same thing for objects 1 and 2. Okay, so now let's figure out how we get from that to what we want. So, okay, so I think compact object 1 and 0 are the ones. Maybe 2 is, yeah. Does this give us our time? So how do we make sure that the time is exactly the same? I had this pulling out at 600. Oh, skip factor of 25. Okay, so F let's go ahead and we'll open it at the very end just so that I've got access to it here. Well, let's take a look at radiative psi4 attribute.keys source. Nope. What's in there? I guess we can look inside one of these. Radius equals 100.00. Attributes, keys. Nope, nothing. Keys here. Time. Perfect. Great. So that gives us the same times that we had there. So um, so this presents us with an interesting problem. We want everything to be at the same times. Do we do the interpolation here? I guess we probably should. But I guess for now, what we should instead do is let's do df0 dot set index time in place equals true. We'll ignore number 2 for now. Let's do df0 x drop NA. Okay, we don't have any NAs there, so df1 x drop NA. Nothing. guess we want to start this around 300 times 25, so around 7,500. That's still pretty far. No, oh right. So what is time? About 1,000. So about 1,000 seconds in. So df0 dot location 1,000 on. 479,521 rows. Wait, why is that? Okay, I guess makes sense. It's about halfway through. Let's do it up to about 2,500, or about 1,250. 120,000 rows. Okay, and now all right, so we will do up to 1,250, skip every 10. Now I only want to output a couple rows, or a couple columns. So columns. Columns, X, Y, and Z. We're only using X, Y, and Z for now. Merger object0.csv. Okay, that worked. Now let's do the same thing for df1, but here, this will be object1. So this now, we don't actually need that, because we are going to import we will import both of them, and now we should have primary and secondary. Oops. We want to add a modifier, but I don't like having that top level one, so we'll do that. So that's primary. Secondary. Okay. All right, that's looks like OBS was having trouble, but now it's not. Anyhow, we've got our primary. Let's go ahead and show what that looks like. Okay, now I'll have to scale these eventually. Oh, and I need to set them to be smoothly shaded, but I can do that in a second. So now let's have our second one. This is our secondary. We'll use our existing geometry nodes. Okay, now let's play it. This should go all the way through to coalescence. Maybe. it does. Cool. Okay. All right, so that is our scene there. You know what? I could probably do it. Let's just do this. We will. Let's do the entire thing, but every 10th frame. All right, 95,000. Import CSV. Here's our primary. This is frame divided by 250. So instead, let's get scene information. No, we want scene info. I guess I can't necessarily get the final frame count. So instead, let's do frame divided by 600, and then we will do end here at 600, and so I'll play that full animation. We'll import a second CSV. This will be our secondary. So we add a modifier, geometry nodes. Okay. So now, if we play from the start, over the course of the 600 frames, we'll see them spiral inward. Okay, great. So we now have these two objects that represent, and here, smooth surface. Set shade smooth, there we go. Oh, I should probably get, here, let's do, is it possible to O1H.toList. Alright, so min radius, let's see, does this give us at any time? Alright, so I can't remember how to use fill NA because I never have to use it. Oh, I guess we don't use it that much. It's deprecated. Alright, I guess I can do interpolate. Max radius, interpolate. Alright. See what it looks like if I do if we use the radius as the input to my sphere, df0 max radius dot interpolate, df1 max radius interpolate, and I might as well do min and max here. So let's do our now I want to look and see how different these things are. So, oh, I got to do this in place. Min radius equals. I guess I could probably just specify the columns, right? Okay, let's take a look at how different they are. Son of a diddly. Oh, right. Okay, let's take a look at df0 max radius minus df0 min radius. It's pretty small. All right, so now let's try something else. We will do max radius for all of these things. We've saved that, so my nodes work. All right, import CSV, gwave, object 0. Now we've got our max radius and min radius in there as well. Let's take a look at what happens if we set our radius. We've got our transform, and we will do our value to our scale. Set named, we have to set our, we've got our points to curve. Let me think about this. Scaling our vector by nothing. So let's remove that. max radius. Set named attribute. So let's see now. What we need to do is we need to write attribute. Named attribute? Yeah, store named attribute. We'll store a named attribute on this, which is, maybe capture is the right thing to do, but I guess it doesn't matter too much. Here, we will store this. Wait, can I read this? Oh, maybe I can. So we got our value there, and we're reading our float value. Okay. That's weird. It starts out very small for max radius. I guess let's take a look at no, it looks like it's not, so that must be an artifact. That's probably an artifact of the frame selection, so I'll come back to that in a moment. Oh, it probably starts out at 0 or something. Yeah. Okay, so if we offset it by 1, then it looks like it should work. Yeah, here, I'll offset it by 10. Okay, and now we will do the exact same thing for our secondary object. Add our modifier, geometry nose, the same one. Okay, so now we've got our mass ratio, or our radii ratios. And when they start to interact, that's when they start should be more dramatic changes to them. Now I'm sure the units aren't right, because the units in, because I think there's like an additional multiplicative factor that's being applied on, maybe not actually, inside Blender, but looks like maybe it's doing okay there. So we've got these. Now what we need to do is we need to sample our modes outside of that and apply those here at the fixed radii. So the first thing I want to do is I'm going to go back here. We are going to create a Python file inside this that does all of our setup here. Okay, so what this is going to do is we are going to take this and we are going to construct a geometry tree from it. Okay, so this is going to be a driver, so we'll have to deal with the driver later. And this will not execute just yet. Now let's go on down here. Let's load up our modes. Yeah, we'll save our orbits. I love this song. Oh yeah, I don't know if I showed this on stream. Did I? Maybe I did. Anyway, I was able to get different modes animated here. And this pulls from VDB files. But these materials are key. So let's copy node tree. That's weird. Alright, well, maybe I can't set that up as a material tree, but no, these are geometry nodes. So let's take a look at the shader. So we've got that shader. Now one of these is a driver, I think. This roughness, oh no, roughness is not a driver, okay. So this takes my attributes from my geometry. So let's go back to the geometry, see if I can figure out exactly what is not copying correctly, and see if I can fix that. Node info default value type name. Okay, so that's something. Let's try. You know, maybe it's just because of the volume stuff. So we've got our sample grid. Let's see if I yank that out. Nope, that didn't do it. Nope, wasn't that one. Ooh, is it the object info? Nope. Which one of these doesn't have the right type? If we can figure that out, maybe if I remove that. Nope. Let's try removing a bunch of them. Let's try just yanking all of these out. That worked. So it's one of those. One of these then. Is it the store named attribute? It's a good song, although I... No. Maybe it's just store named attribute as a whole that's the problem. No. Okay, so now what we need to do is we need to capture those 3 additional store named attributes in there. So that's where I think I'm going to have to leave it for today. But we've now got put this back where it's something interesting, so at least that shows up. Yeah, so this is what we're going to put around our orbit. It would be nice if I didn't have to mess around with writing a bunch of additional stuff, but I guess that's what I'll do. So we got most of it put back together. Not all of it, but most of it. And we will continue on with this, possibly even later today, bringing all the different components into one scene. Ideally using a single script to set up all of our different values, or all of our different node trees and so on, so that we can reproduce it just from the start. Okay, thank you for joining me.